Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're factorising quadratic expressions, our third video on this topic so far. Let's start with something we already know. Previously in our manipulating algebraic expressions topic, you would have factorised the following two types of expressions. Pause the video and double check you can do that. Well, in the first case, I would have expected you to look at the numbers 2 and 20, decide the highest common factor, which is 2, factorise that out. There's an x here but no other algebra here, so we'd have x add 10. And here, the difference here was the word completely. That gave you a hint that not only do you have to factorise out some number, but also some algebra. So similarly as before, the highest common factor of 2 and 20 was 2, but this time you had to look at x squared and x and decide, well, there's a factor of x in both of those. And then you would have put in your bracket x add 10, like before. So that was the difference between a simple factorise and a factorise completely. Do go back to manipulating expressions and your factorising basic expressions if that doesn't make sense. And we're going to use that idea in this video. Just before we do that, I just want to do a tiny bit of expanding to show you the type of expressions I'm dealing with. You know, in the past I've asked you to evaluate this. Pause the video and double check how to do that. Well, hopefully you thought to yourself, because multiplication is commutative and associative, I can do the 2 multiplied by 5 first, which is 10, and 18 multiplied by 10 is 180. Now, if someone asked you to expand 2 brackets x plus 2 x subtract 5, what would you do? Well, you know what? I wouldn't do the multiplied by 2 till the very end. I'd keep that there, like I kept the 18 in the previous case. I'd expand this, which I should be able to do quickly, as x times x is x squared, positive 2 and negative 5 are negative 3x's, so I'd have negative 3x, and positive 2 multiplied by negative 5 is negative 10. And then what I do is I times everything by 2 at the very end and get myself 2x squared, subtract 6x, subtract 20, and I'd be done. So I just want to point out to you, it's these type of expressions we're going to be factorising in this particular skill, where there is a common factor of 2 in this case, let's say, or a common number factor in each of the three terms, which you might be able to factor out first, and then after that you would take the algebraic expression here and factorize that into 2 brackets. So that's what we're trying to do in this video, and let's do an example to show you what I mean. Right, factorize completely the following 2. If you feel like you can do it, pause the video, otherwise I'm going through now. Now, before I launch into these, I always check the coefficients, the 2, the 10 here, and the 12, and say, is there a common factor in 2, 10, and 12? Yes, there is. The highest common factor of them is 2. So I could factorize out the 2 first before I do anything else. What would be in my bracket? 2 times what gives me 2x squared? Well, x squared. 2 times what gives me positive 10x? Well, positive 5x. 2 times what gives me positive 12? Well, positive 6. Okay, and now this quadratic expression, I can factorize that into 2 double brackets, having done the factoring out the 2. And that would be 2, and I'm thinking of 2 numbers that multiply to positive 6 and add to positive 5. I know those. They're going to be x add 2, x add 3. And I'm done. That's the complete factorization. Firstly factoring out a number, then factorizing the algebraic expression into 2 brackets, and I'm done. What about this one? Pause and have a go. First thing, I'm going to look at the 5, the 15, and the 50. Does it have a common factor? Absolutely, it has a common factor of 5, which is step 1. I'm going to factor it out. 5 times what gives me 5x squared? Well, it must be x squared. 5 times what gives me positive 15x? Must be positive 3x. 5 times what gives me negative 50? Must be negative 10. And I've done my first stage. Now it's time for me to have a go and factorize this quadratic expression. I'm looking for 2 numbers that multiply to negative 10 and add to positive 3. Keep that 5 where it is, don't get rid of it. And I'm going to get myself x subtract 2, x add 5. How do you know that works? Negative 2 add 5 is positive 3. Negative 2 multiplied by positive 5 is negative 10. There's the complete factorization. Done. Next, please pause and do try these before I go through them. Same old stuff here. The first thing I'm going to do is think about the number. Is there a common factor in 2 and 18? Absolutely there is. Factor of 2. I'm going to factorise that out. What must go here? 2 times what gives me 2x squared? Or simply an x squared. 2 times what gives me negative 18? Must be negative 9. Now how do we factorise these? Do you remember factorising quadratic expressions too? This is a difference of 2 squares. Remember, we know that x squared take away y squared factorises to x take away y, x add y. That was called the difference of 2 squares. Now I know that 9 is really 3 squared. So how does this factorise? Keep the 2 there. This will factorise to x subtract 3, x add 3. Done. Do the same thing here. Highest common factor of 3 and 75, well, that's going to be 3. And I would get inside my brackets 3 times what gives me 3x squared, must be x squared. 3 times what gives me negative 75, must be negative 25. Now 25 written as a square is 5 squared. So this is of the difference of 2 square forms, x squared take away 5 squared. So this is going to be 3, x subtract 5, x add 5. And the last one, look for a common factor of 404. There's definitely one there. I'm going to take out a common factor of 4. In the bracket, I'll be left with 100 subtract x squared. Now 100 can be written as a square, it's 10 squared. So this would factorise to 4, 10 subtract x, 10 add x. And that's it for this video. Thanks very much for watching.